SwayamPrabha. Digital India. Educated India.
Okay, today we will be looking at programming the PUMA robot using VAL 2 language. So, PUMA robot was the earliest robot 1960s, which was made by the Unimation company. So, PUMA stands for Primary Universal Machine for Assembly, and this robot was made for assembly. And the structure of the robot is essentially, it is almost similar to the human body, the arm. So, the first joint of the robot is what is called the waist. So, this is the teach pendant by which we can move the robot and also program the robot. So, this is the teach pendant which has the joints 1, 2, 3, 4, 5, 6 joints, and this is having toggle keys plus minus plus minus. So, if I move any of the toggle keys, then essentially this the robot is going to move. So, the first joint of the robot is the waist axis, which is similar to our waist. So, when I move my hand, we move across the waist. So, this is my waist axis, and my hand moves like this. So, this is my z axis about which I am rotating. The second axis is this one, which is called the shoulder. So, when my hand goes up and down is the shoulder axis. The third axis is the elbow axis, which is like this, which is called the elbow. And then at the wrist we have the roll axis, the pitch axis, and the yaw axis. Okay. So, we have 6 degrees of freedom, and similar to this we have exactly 6 degrees of freedom on the robot. So, the first axis is called the waist axis, which is similar to the human waist, and the direction of the axis is vertical, as you can see there. The second axis, let me turn it this side. So, this is my waist. The second axis is the shoulder. So, in the shoulder axis the hand can move up and the hand can move down. Okay. So, this is called the shoulder axis, moving the hand up and down. The third axis, which is similar to our hand, is called the elbow axis, and this is my elbow axis, which is moving the arm up and down. The fourth axis is called the roll axis. So, that is my roll axis, which is rotating the wrist at the wrist. Okay. So, this is called the roll. The fifth axis is the pitch axis, which is putting up and down the end effector. So, this is my pitch axis, and the sixth axis is the yaw axis, which is in this case it is looking as a roll about the z axis. So, the last 3 axes, the fourth axis, which is the roll axis, the pitch axis, and the yaw axis, they are intersecting at a point, and this is required for having an inverse kinematic solution. So, we can program this robot by using the teach pendant, which is shown here, or we can write a program. Now, in our earlier classes about VAL language programming, we have seen that the basic commands which are used in VAL are moves to move the robot arm from one point to another point. So, the first thing that we have to do is to define a point in space, and we define points in space by assigning the variable name, say point P1, and giving a coordinate. Then we say move P1 or move P2, and for the gripper we have open close commands. So, the essential commands that we are using in VAL are point, move or moves, open close, and approach and depart. This was covered when we talked about VAL language programming. So, what we will do today is we will write a very simple program for this robot. So, suppose the robot is in one end. So, let us move the robot to one end here to one side, okay, and say that this is my point P1. So, what I am doing is, suppose there is an object on this table. Suppose I want to pick up this object on the table, okay, and this is the robot, and if you can imagine the robot to be same as my hand. So, I say that my hand is here and this point is P1. So, this is equivalent to the point P1 there. Okay. So, then if I want to pick this up, what I do from P1, I will come to the point P2, which is very near or just on top of the object, and from here P1 I come to P2. Then this is my P3 point. I will go down and catch this object, take it up to P2, take it to P4, some other point, and then drop it and come. Okay. So, what we are basically going to write a very simple program. The hand is somewhere called a point P1, then I will come to a point P2, then from P2 I will open my gripper, I will go down, I will approach the object and keep a distance of 150 from the object. Then I will go down and catch the object, okay, and then after catching the object I will depart. So, it will come up again, okay, and after coming up to this point P2 again, it will go to the point P4 and then maybe drop the object and then come back to P1. So the program would essentially mean coming from P1 to P2, opening the gripper, going to P3, coming back to P2, going to P4, opening the gripper, and then going back to P1. So I will basically write down or draw the sequence here. So we are at a point P1. Let's call this point P1. So the robot is at a point P1 now, and there is some object here which I want to catch. Let's say there is an object kept on a table that I want to catch. This is my point P3. Okay. So the program we will write would be that from point P1 it will come to point P2. This is my point P2. Then it will open the gripper, and after opening the gripper it will go down, okay, and come and wait to the point which is just about 150 on top of P3. Then it will come to P3, close the gripper, and then go upward again to P2. Then from P2 it will go to P4, some other point, open the gripper, drop the part, and then it will go back to P1. So this is the sequence for which I'm going to write the program using VAL language. So point P1, it will go to point P2. So you can look at the program here, which I have written very. So first is edit demo 1 means the name of the program is demo.1. That's the name of the program. Then move P1. So the robot could be somewhere else. So before it starts the operation, it should move to point P1. So the first line is move P1. P1 is the point which we have to define. We'll see how. Next is it moves to point P2. So it moves to the point P2. Okay. Then it has to approach the point P3. So we have seen when we studied VAL language that we don't directly go to the point P3, but we come somewhere on top of the point P3 and wait there using the approach command. So the approach command will ensure that it will come here and it will stand at a distance of 150 on top of the object. Okay. Okay. And then we are going to open the gripper, which is open eye. After opening the gripper, it will go down to P3, so moves. So please note that this is move and this one is moves, so it will move in a straight line and go to the point P3. Then it will close the gripper, and then it will depart, means it is departing, it is going straight up by a distance of 150. Okay. And then it moves to P4, so from here it will move to P4. So from here, so this is my point P4, and from here it will move to P4. So this is the point where it departs, and then from here it will go to P4. Now after going to P4, so move P4, it goes to the point P4, and from P4 it will come back to the point P1. Okay. Sorry, in P4 it will open eye, drop the part, and then it will come to the point P1 here. So we can keep repeating the cycle a number of times. Okay. So the basic program, as you can see, consists of the move commands, which means move to this point. Then it is approach. We said that when we are catching an object, we don't exactly go to the object, but we come somewhere on top of the object and wait with approach, open the gripper, and then go down straight. Okay. And that is done because to ensure that always the catch motion is straight and the depart motion is straight. Okay. So we are using the approach command here and the depart command here. So the basic commands are move, approach, open, close, depart, and that's it. So using this, we can write the program to perform this cycle, where the robot from one point will go to another point, catch the object, pick it up, go somewhere else, drop it, and then go to the third point. So I'll write the program very quickly. I'll type in the program in the so this is the monitor, and this is the keyboard, where this is using basic like structure, basic like commands. So I'll type in this in the command, and then I will execute it. So exactly this program I'm going to type in. So edit. So edit demo.1 is the name of the program. Okay. So the first command is move P1. Okay, let's use some other name. Let's call it some other name. So demo.1 is already there. So let's say demo.5. Okay. So demo.1 is already here. So I'll just change the number to demo edit demo.5. So that's a new program. Okay. So it says program demo.5. Okay. So that's the name of the program. So the first line I will type exactly this command in that sequence. So it is move P1, that is move to the point P1. Then we say move P2. Then we say approach the point P3 and keep a distance of 150. Okay. And then we say open open I, which means open immediate, then moves P3, that is the point where the object is kept, and then we come to close I, and then it is departs 150. So after catching the object, it will depart, go back straight 150, which is here. So it goes back to this point, and then from this point we wanted to go and drop it at some other point. So P4, so we say move P4. So it has moved to point P4. So after moving to point P4, it is opening the gripper and dropping. So we say open open I, and after that it moves back to the start point. So from here it moves back to the start point P1. So we say move P1. Okay, so we have entered exactly these commands in the monitor by using the keyboard. Okay. So now next what we need to do is, we have written move P1 or move P2, but it doesn't know what is the points P1, P2, so we have to teach it the points P1 and P2. Okay. So I will start off by teaching it the points, the P1 and P2. So for teaching the points, I can use the teach pendant. So using the teach pendant, I toggle the joints and I say that is my point P1. Okay. Suppose that is the point P1, that is this point, okay, in space now. So now what we will see is, we will say here is the point P1. Okay. So the command that we use here is called here P1. So with this it understands that this point is actually P1. So now when I say right here P1, it will actually show me the coordinates of the point P1 in space now. Okay. So you can see that it has 6 parameters, the x, y, z, and the theta1, theta2, theta3 at the end effector. So the x coordinate is 663, the y is -78, z is 427. This is in millimeters. So the base coordinate of the robot is 0, 0, 0, which is at the base there at the waist of the robot, and this is the x, y, z, and theta1, theta2, theta3 are at the wrist. So now if it is saying that, do you want to change this? So I say yes. So now it has assigned this coordinate to the point P1. Okay. So we have taught it the point P1. So next I want to teach it the point P2. So what I do is I move this here, let's say. Okay. So I move it here, and this comes down a little bit more. Okay. So this is my point P2. So I will teach it again and say this is here P2. Okay. So again it is giving me the coordinates of that point. If I am happy with the coordinates of the point, I will enter, and it understands that this is the point P2 that I want. So I enter here. Now I have taught it the point P2. Okay. So that is the point P2. Now I want to teach it the point P3, which is let's say a little bit down. So I bring it down. So I bring it down here and say that is the point P3. So this is the point P3 where I want to pick up something from. So I will teach it the point P3 as that point. Okay, so that was my P3 point. So I will say here P3, and that is the point. It is also giving me the coordinates of the point P3. Okay. Now I have taught it the points P1, P2, P3. I have to teach it the point P4 now. So that is maybe that side. So I move the robot that side where I want to go and drop it, and so maybe it has to go and drop it at some other point that side. Okay. So that is my point P4. Okay. So again I will teach it the point P4 and say here is P4. Okay. So it understands that this is the point P4. So I have taught it P1, P2, P3, and P4. Okay. So now I have taught the various points P1, P2, P3, and P4, and I am going to execute the program now. Okay. So the program, before executing the program, we have to set the speed. So speed command is speed. So we have to say speed, and if you are operating at, say, slow speed, it is at 20%. This is a percentage. So if it's a small speed, we are saying it's so full speed is 100%, lower speed is 10% or 20%. So let's say we are putting speed as 20. Okay. So after putting the speed as 20, I will execute the program. So executing the program has the command of execute. So execute demo .5. Okay. So this command essentially the robot understands that I want to execute this program, and the program name is demo.5. Okay. So I am going to execute the program. Now when we are executing the program, okay. So you can see that we are starting with point P1. So this was the point P1 that I taught it. Okay. So it is coming to the point P1, then it is going to the point P2. You can see exactly this sequence it is following. Then it's going down, approach, and stopping. Okay. So the exact sequence of operations that it was doing is it was going from P1. We'll see that again. So this is the exact sequence of operations it was following. That was my point P1. Then it went to point P2. That was somewhere there. Now, before it went to point P3, we are using approach. So it is approaching the point P3 and waiting at a distance of 150. So it was just coming down and waiting at 150. Then it is going down straight because there is a straight line command which is move S P3. So it is coming down, and then it is going backward again, which is after close I, it is departing 150, and then it is going to P4 and then coming back to P1. So this is the cycle in which we are operating. So this is an example of how to write a very simple program. Now the gripper is pneumatic. At the moment the pneumatic is not working, so it is not opening and closing, but the open is open eye and close is close eye. Okay. So if you are trying to catch an object, we have to open the gripper before we catch the object, and after positioning at the gripper, we have to close the object. So this is for one cycle. If I increase the speed to 100%, okay. So using speed command, I have increased the speed to 100%. Okay. So I'm going to make it 100% speed now. So I will simply say 100. So it is operating at full speed now, and so let's say speed. Okay. So this is operating at a higher speed, but it's following the same sequence of operations that you can see. Okay. Now a robot is not used for only one cycle or two cycles. A robot would be used for performing very large number of cycles, maybe millions of cycles. So for that, what we can do is we can say execute here demo.5, and we can write how many number of times it should execute. For example, if I want it to execute 10 times, then I'll simply write the number of cycles I want it to execute. So the command is execute demo. This is the program name, comma, and this is the number of cycles that it has to operate. So let's write it here as execute So we are saying execute the program demo.5 10 times. Okay. So the command is execute demo.5 is the program name, and 10 times is the number of cycles. So we are looking at, so this is operating the same cycle, but it will be doing the cycle 10 times. Okay. So in industrial applications, normally the robot will not be operating only once, but it will be operating for a very large number of cycles. So it has a counter, and it is also saying that program has been completed and it has executed 10 number of times. So there is a counter which keeps counting each cycle, and the moment it has reached 10 cycles, it will stop. Okay? But the sequence of operations was exactly the same. So we can write very simple programs using VAL2 language like this, using very simple commands like move, approach, open, close, and execute pick and place applications, spot welding, spray painting, different applications. Now, in the earlier lectures on VAL2 programming, we had talked about two commands. The first one was the difference between the two commands move and moves. So, there is a command move and there is another command moves and moves. Okay. So, this one basically takes the robot from one point. So, if I have a robot like this, okay. So, this is let us say move P1 or let us say move P2. This is my point P2, this is my point P1. Okay. So, if I say move P1, what it will do is, as there are different degrees of freedom here. So, there are theta 1, theta 2 up to theta 6. So, what it will do is to go from here to here, it will find the minimum energy trajectory. Now, the minimum energy trajectory will not be a straight line. So, when it is moving from here to here, it will not take a straight line, but will take some other curved path in space, okay, but not a straight line. Whereas, if I use the moves command, then what it basically means, suppose I say moves P2, then what it basically will do means it has to follow a straight line and come from P1 to P2. Now, following a straight line takes more energy. Okay. So, unless it is required, this is not used. So, this command is not used unless when required. So, if it is just moving, we say move, but when we want it to follow a straight line, when it is picking up an object or dropping an object, then we are using the command moves. So, let us look at these two examples. So, that is my point P1. Let me take it somewhere else. So, this is my point P1. I have already taught it P1. So, let me write a program which will take it from. This program is essentially to show the difference between the two commands, move and moves. So, we have move P1, let us call it edit demo.6, that is the name of the program, move P1, and then we say move P2, okay. And so, suppose I am here, this is my point P1, this is my point P2 in space somewhere, okay. So, I am saying move, so what it will do is it will take some other trajectory, and then I say move as P1, okay. So, from here to here it is going by following the command move. So, it is not taking a straight line, but taking some other trajectory, minimum energy trajectory. Then I am saying moves P1, so it is coming from here to here, and it is now in this case it is going to follow a straight line. So, we want to see the difference between this and this. So, let us write this program and see how it behaves in space. So, this is to understand. So, this is the point P1. So, let me teach it another point. So, let me teach it some other point P2. So, P1 is already known, right. So, that is my point. So, let us say that is my point. So, that is my point P2. So, what I do is let me write this program. Okay. So, here I am going to write a program again. So, edit demo.6. So, this is another program called demo.6. So, essentially this program says move to the point P1, move P1, okay. Then I am going to say move to the point P2. So, it has moved to the point P2. So, I am at P1, I am saying move to the point P2, and after it has gone to the point P2 taking a curved path, I am saying move in a straight line back to the point P1. So, now I am saying moves P2, okay. So, this is a very simple program to move between 2 points. Once it is going to move in a curve, and then it is going to move back in a straight line. So, that point let us teach it as P4. So, that is my P2. So, this is my point P2. So, I teach the point P1 is already learnt, P2 is the point which I am teaching it now. So, let us cut down the speed to 20%, then execute. So, first wherever the robot was, it is coming to the point P1. Right. So, it has come to P1. Now, you can see that it is going in a curve. If you can see that it has gone from P1 to P2 in a curve, but it is not being able to come back in a straight line. So that error is coming. So now let's change the coordinate a little bit, and so let me bring it there itself. And teach this as point P2. So here edit demo.6. Okay, so let's try to move it down a little bit. So this is my point P2. Let's move it to some other point. It is not being able to find the trajectory which is coming back this way. So it is going to come back using a straight line only. Okay, so this is basically showing how the robot can move from one point to another point. Let us bring it here. And say this is my point 3. So let's teach this as point 3. So now what I'm saying is P1 is here, P2 is here, and I define another point which is P3 here. Okay, so let's try P3. So what I will do is we will say move to P3 by using the move command, and then it will go back using the moves command. Okay, so these are two different commands to go from P1 to P3. So let's have a look at that. Okay. So what we have done here is we have written a program to take it from P1 to P2, then move, and then it moves in a straight line. Okay. So let me write the program again. So it is going starting from move P1, then it moves to P2, and then it moves to P3. P3 is another point, let's call it P3, and then it moves back to P1. Okay. So we have 3 points. We have P1 here, so it's my P1. This is another point P2. This is the point P3. Okay. So it goes from here to here, then it goes there. Now from here to here, we are using the straight line command, so it should move in a straight line. Okay. I basically want to show the difference that from here to here is going in a curve, then here is going in a straight line, and when it is coming back from here to here, it is again going in a curve. Okay. So I basically want to show the difference between the command moves and moves. So P1, P2, P3 is taught, so we have to teach it the point. If that's my point P3 here, P3. So I've taught it the 3 points, P1, P2, and P3. Okay. So P1 was already taught. It is somewhere on top. So this is my point P2. Okay, so let's say that's my point P2. Here P2, and my point P3 is somewhere here. Okay, so that's my point P3. Sorry, that's my point P1. So from P1 it is going to the point P2, then is going to the point P3. You can see that it's moving very slowly because it is going in a straight line, and then P3 is going back in a curve. So this is essentially to show that when we are using the command moves, the robot actually moves in a straight line, and it becomes very, very slow. And the speed, it becomes very slow here because it has to compute that straight line path and then go in that speed. So if I increase the speed to 100%, okay, and then if I cycle it, let's say 5 times, okay, so I've increased the speed, and I'm also executing the cycle 5 times, okay. So basically to observe that when it is going from here to here, it is going at high speed, but when it is using the moves command, okay, so when it is moving to the point P3, it is going very, very slowly because it has to go in a straight line. And then from P1, so from P3 to P1 again, it is going very fast. So this is essentially to show, so if you see the motion, the curve motion is very fast, but the straight line motion is very slow. That is essentially because it has to do more computation. The inverse kinematics is more difficult. So the moves command is only used for when you have to pick up an object and you have to go in a straight line, not